So we're going to use Kirchhoff's current law to solve an actual circuit. This is the first time you see a dependent source, and this means a current source because it has an arrow and it's dependent on another current, 3 times I. So the value of this current source is 3 times this I here. So the question is, what's I? And to start, you see this is a 2 milliamp current supply, and it's in series with this current. So in this case, 2 milliamps is coming into this node, so I'm going to say the Kirchhoff's current law from node 1 is 2 milli plus I, both are coming in, equals 0. There's nothing coming out, and therefore I equals minus 2 milliamps. And this gives me the answer to the 3I, which is going to be minus 6 milliamps. I'm going to do the same thing here for node, I'm going to call this my node 2, and later I'm going to call this my node 3. So I'm going to make Kirchhoff's current law for node 2 and node 3, which is minus 6 milliamps coming into the node equals I1. So this is my answer for I1 already. This is my answer for I. And now I'm going to find I3 by looking at node 3, which is everything coming in, I3 equals everything coming out, minus 6 milliamps. So this is I3. And now, looking at this, I can potentially find I5. So I'm going to go for node 4 is this one here. So I'm now looking at node 4, and everything coming into it equals, it's nothing, equals everything coming out, which is 3 milli, plus I plus I5. Now I equals minus 2 milli. Therefore, I5 equals minus 1 milliamps. Now I can find I6, so I'm going to call this my node 5. Node 5 is going to be everything coming in. I5 plus I6 equals 2 milli. Everything coming out. Now I know I5 is minus 1 milli, and therefore I6 equals 3 milliamps. Now I know I6, I know I5, I'm going to find I4 with this node here, node 6. And I may have to use this side of the board. I apologize, yes, node 6, which is going to be everything coming in, which is the 1 milli, equals everything coming out, which is I4 plus I6, 1 milli. And now I know I6 is 3. So I4 is going to be 1 milli minus 3 milli. I4 equals minus 2 milliamps. I4, 6, 3, and I think the only thing left is I2. And this node is really interesting because everything is coming into it. Node 7. Actually, I potentially could get I2 from node 8 down here, so I'm only going to do this final one. Node 8. Which is everything coming out, so 0 equals 1 milli plus I3 plus I2. And I know that I3 equals minus 6, so I2 equals 5 milliamps. And this is how you solve a Kirchhoff's current law circuit.